Come on, I'm gonna be late.
Coming.
Hey, John, what's that noise?
I don't know. Oh, Paul, you alright?
Oh, my arm. Where's my arm? This is the third video log, 1 hour 105 of the disaster. We have acquired food from the cafeteria, and my friend is attempting to acquire parts for a radio that I've been trying to create, as we have no means of communications. My arm has been incapacitated in the blast, and I'm going to try to get John to build it.
Oh, got some parts.
You do?
Yeah.
Really? Well, I suppose we should commence then.
Okay.
You do know what we're trying to build, right?
No.
A radio! Oh dear. Alright, John, so the first thing that I need to talk to you about is waves. And you're gonna find out what they are, too!
Paul, stop breaking the fourth wall.
Alright, I'm just trying to be engaging. Now, John, what's a wave?
Thing that blind people surf on?
Well, that's one kind of wave, but it goes deeper than that. There are actually two kinds of waves. Mechanical, like the waves that you were talking about, and then also sound waves, among others, and electromagnetic or EM waves.
What does that have to do with making a radio?
Now, I'll get to it. There's also two shapes of waves, transverse and longitudinal.
Hey, whoa, how did we get here?
I don't know. We're just in the stairwell. How do we keep jumping back and forth?
Quantum physics?
Whatever. I'll show you with this handy-dandy slinky.
First of all, it's tangled, and second of all, you kept a slinky during a nuclear apocalypse.
Always come prepared, John. Now, throw one side to me. Throw one side to me. That never happened. Okay. Now, move the slinky side to side. What you're seeing now is a transverse wave. The waves are going perpendicular to the wave movement. Now, stop it, John. Now move the slinky back and forth. What you're seeing now is an example of a longitudinal wave. In this case, the wave particles are moving in the same direction as the wave movement.
No, it is. Wait, what's the difference between mechanical and EM waves?
Mechanical waves require a medium. A medium is something for the waves to travel through, such as water or air. EM waves don't. Now, all waves have the same basic anatomy, though, as you can see from the poster.
Got a visual aid?
Never leave home without it. Bring that up to the camera for us. Why don't you? Further. Now, as you can see from this wave diagram, all waves have certain things.
Hey, Paul, get at your tentacle.
This is, by the way, a proboscis that I grew at some point. Okay. As you can see, it has a crest, which is the top part, and a trough, which is the bottom part. It also happens to have a wavelength, which is the distance from either crest to crest or trough to trough, and it has a frequency, which is the number of wavelengths that pass an area at a given time, and amplitude, which is the height of a wave. Next on the list is sound waves. Now, I want you to sing and feel your throat. You guys in the audience can do it too.
Paul!
Okay. So you feel it vibrating, right?
Yeah?
That's because sound waves are mechanical waves caused by vibration. Sound waves are always longitudinal and travel via compression and decompression, or also called rarefaction. The frequency of sound is basically the equivalent of pitch.
Really?
Yes!
What? WTF?
Yeah, I think being trapped in a stairwell is driving me a little bit crazy. Yes. Well, on to light. Now, EM waves are all transverse, and they're able to travel through empty space. Look at your shirt. What color is it?
You know my jacket?
Your jacket.
Blackish gray.
Now, as a general rule, light from the sun is white. In light terms, white is a combination of all colors. But the reason that your shirt is gray, well, your jacket is because only the gray light reflects off the shirt and enters your eyes. Now, the light that you see is only a small fraction of all light. In fact, there are many different kinds of light. There are many different kinds of light unseen by you and me. From biggest to smallest, the wavelengths are the following, as you can see on this proboscis handy-dandy visual aid.
Hey, let me hold it.
All right.
Proboscis is creeping me out.
Yeah, I know. As you can see here, the first kind, from biggest to smallest wavelengths, is the following. First is radio. The biggest is AM, then FM, TV, radar, and radar. After that comes infrared waves, then visible light, which goes from biggest to smallest: red, orange, yellow, green, blue, purple. Then you have ultraviolet waves, then X-rays, and finally gamma rays.
You mean like in comics?
Yes, but they don't actually work that way.
Aw, I'll be green and angry.
Look at this green.
Wait, what did I hear about radio waves?
Aha, now on to radio. Now, radio requires a microphone, a transmitter, and an antenna. Do you have this stuff?
Yeah.
Wait, do you know about the history of waves?
Yeah.
Oh,
I actually did a science project on it once. Supposedly, Nikola Tesla was the father of modern radio. He actually invented radio, but it was his co-rival and part-time tutor Thomas Edison that published it. They stayed mad at each other for years.
really?
Yeah, I know.
That's
Pretty
interesting to know. So, do you want to know how to put the radio together?
Guess so.
So first, you need to make sound into the microphone. The microphone, the microphone then turns sound into the electric signals. Then the electric signals in the transmitter turns the electric signals into radio waves, which are these waves on the spectrum. These waves on the spectrum can then travel to another antenna anywhere else in the world on that frequency, whether it be AM, FM, or shortwave. These radio waves then go... So, do you want to know how to put the radio together?
Guess so.
So first, you need to make sound into the microphone. The microphone then turns sound into the electric signals. Then the electric signals in the transmitter turns the electric signals into radio waves, which are these waves on the spectrum. These waves on the spectrum can then travel to another antenna anywhere else in the world on that frequency, whether it be AM, FM, or shortwave. These radio waves then go out of a different microphone and turns them into sound waves again, allowing you to make sound travel very, very far distances, far more than you would be able to do by, say, yelling.
Wow, so that's how the radio works?
Yep, you ready to put it together?
Sure.
Man, I'm glad that we happened to find all these wires.
Yeah, I know. It's just like, out of all the stuff that survived the blast, there's the stuff to make a radio.
I know. That's
so convenient.
It is.
Wow, that was hard.
Yeah, you almost electrocuted yourself 6 times.
Tell the audience that.
See, now you're breaking it.
Oh.
Well, let's hook it up.
Okay.
Proboscis!
Testing. 1, 2, 3.
Is anybody there? Is anybody there?
We're saved! Proboscis!